Hello, this is Peter from OneCNC UK. And what we're focusing on in this video is XR7 Mill Express. Mill Express is our 2.5D package, which will help you dramatically reduce programming times, improve the efficiency of your machine tools with our high-speed machining cycles, giving your machine shop greater capacity. So let's get started. So on the top right hand side of the screen, you'll see a blank toolpath group. This is where we keep all of our toolpaths, and it's also where we store our post processes. So if we right hand mouse click on toolpath group, go down to post group, on the top right hand side of that form is where we keep all of our post processes. So everything from Achromatic, Aniline, Bandits, Boss, Fanucs, Hasses, Heidenhains, Hercos, Shop Mills Siemens, Mazaks. So you just select the post process of your choice and select OK. You won't notice the post process coming into play until you start looking at your whole operations, when the applicable questions will pop on the screen for your CAN cycles. OneCNC is broken up into three main areas on the left hand side. We have our drawing options along the top section, we have our model tools in the middle, and we have our stock tool paths down below. And there are multiple ways we can work with inside of our software. We can use our drawing options, points, lines or arcs to create our own drawings from scratch. We can import customer drawings, DXF, DWG files, and put our cutter paths direct around there, or we can input solid models and extract the edges from the model and put our cutter paths around there. So we'll start off with creating a drawing from scratch. OneCNC has a powerful suite of drawing options, from points, where you can create points at arc centers, points along a chain, lines, which will allow you to do horizontal lines, vertical lines, angled lines, tangential, rectangular, parallel offsets, sketch lines or chamfers. And we have arcs, which will allow us to do full circles, arc sketching, arc through 2 points, arc through 3 points, fillets, ellipses, helixes, optimized lines, cardinal splines, B-splines and Bezier splines. So when you're working with points, lines or arcs, there are three methods of input. You can input via the world coordinates directly around your X, Y and Z, just by simply typing in the start points of your lines or tangential lines or angled lines and then just selecting OK. You can use your incremental values, or you can use the snap grid that is available on the screen. So let's have a quick look and just do a very simple drawing using the snap grid. So we're going to go into lines. So we're just going to draw ourselves a very simple shape using the snap grid. With inside lines, we can obviously put chamfers on there. When you use chamfers, when you select the line, it will automatically give you a preview of the chamfer that you're about to produce. This box is still active, so if you wanted to change the chamfer size over, it can just be done at the click of a button. So we'll stick with a 10mm chamfer. We'll just drop a few chamfers around here. As you can see, it doesn't matter whether you work counterclockwise or clockwise. Let's put a few fillets on there. So we're going to arc, fillet, same thing applies. Select the size of your fillet that you want to put on and a preview appears, so you can obviously preview what it's going to look like before you left click to select it. So very quick and easy functions to put fillets and chamfers on. And when you're working with points, lines or arcs, as I said, OneCNC has an intelligent cursor as well. So you can snap to the beginning of lines, you can snap to the middle of lines, you can snap to the end of lines. If I just drop an arc over on the right hand side, just change the radius a bit, you can also snap to the 4 quadrants of the circle. So it makes geometry input very quick and very simple. Also with our trimming options, several different options available: scissors, scissor sketch, trim 1, trim 2. I'll just use scissors just to trim these arcs back to the nearest intersect point. And so as you can see, you can create quite complex geometry very quickly. So when you created a drawing, you might want to put some dimensions on there. So go into my dimension options. We've obviously got horizontal dimensions, so you can just snap away to any intersect point. I can just grab hold of the edge of those chamfers as well if I require it. Vertical dimensions. And radial and diameter, and also you've got angle dimensions in there. So let's just go for a radius. Now when you've put any dimensions on here, you might want to modify them. You might want to put tolerances on there. So if I'm just going to edit a dimension, let's left click on R15. We might want to put some information after it. So maybe that's typical. So we'll just do tip. We might want to change the height of it. So maybe just 2.5. And we might even want to put a tolerance on there. So these are our options of tolerances: above and below the line, up and down tolerance, or plus and minus. So we'll just go for plus and minus on this one, and maybe we're going to give it a tolerance of 50 microns. And we can select OK. So a full suite of drawing and dimensioning tools available. Very quick, very powerful. Another thing OneCNC comes with is its own library of drawing boundaries. So if we just go into file, we'll bring a file in. As I say, this comes with OneCNC again. All of these files available. You can import them your own. You can bring these in. You can modify them to suit yourself. And it's just a question of selecting the file size that you want and selecting OK. We'll just grab hold of our drawing using the color selections. So I'll just grab hold of my drawing, which is in the 2 blue colors, and then we'll just use our transform options and just move that into a more sensible place. So again, we can modify anything on these standard forms that we bring in. If I wanted to change the title over, I could just go into my text options. I want to edit some text. You just simply left click on the title, and we'll just call this one demo for now, and select OK. Now, as I say, you can fill these in with your materials, your standard tolerances, and you can save them again for use on another part. Or, as I said earlier, you can import a drawing boundary that you already use and drop it straight into our libraries. So very quick, very simple. So as I said, we can create our geometry using our suite of drawing tools. We can put our tool paths around there. The other way we can work, or one of the other ways we can work, is import an electronic drawing. So if we go into Windows, we'll just open up another file, and we'll bring in our customer drawing. So we could obviously put our toolpaths directly around this geometry, obviously providing it hasn't been scaled. In that case, then using our transform options, we could scale it back up. Or the third and final way we can work is using solid models. So there we have our imported model that the drawing was taken from. So we'll have a look and see how quick and simple it is for OneCNC to extract the edges of this model and create its own toolpaths. So as you can see, there are some layers down on the bottom right hand side of the screen. Layers are basically like pages of a book. They're there to make your life easier. More complex drawings or complex geometry you have on the screen, the chances are that you can pick up the incorrect piece of geometry. So you can add layers, so you can turn the other things off so they don't get in the way. So I'm just going to add a new layer just by left clicking on the little plus button, and I'm just going to rename this to toolpaths. Now what we need to do is extract the edges from this model to create our 2D 2.5D toolpaths. For this we use our model tools over on the left hand side of the screen. All I want to do is extract an edge, and I want to extract to give myself a full profile. So it could be on the bottom of the chamfer, or it could be on the base of the profile. It doesn't matter where you extract these edges from, it's the plane that's sat on the job, which is this XY default plane. that controls the height of the tool path. So we're just looking for a full profile. So you hover over an edge and left-hand mouse click. That will then track the geometry all the way around, and I also need the geometry for these two pockets. So again, simply left-hand mouse click and then right-hand mouse click to finish. And you'll see a green eye appear by the toolpath layer. That's telling you you've extracted the geometry successfully. There's geometry on that layer, and that layer is open. To turn any layer off, you just left click on the open eye. So I'm just going to turn the model layer off so you can see what we've just done. As you can see, if I just view that from a standard plane view, all I've done is basically created the profiles directly off our customer model. The only thing I haven't done is extract the edges of the holes. Well, there is a model sat behind here in this layer. OneCNC has an intelligent cursor. It has a feature recognition system, so it will find those holes for us. I don't need to extract the edge from those holes. So all we need now is a description of the shape of the billet, and we can use that for two things. We can create a boundary from it to machine any excess stock off the top face, and we can also simulate to it, so we get a very accurate simulation of everything that's going to happen on your machine tool before it even goes out onto the shop floor. Of our billet. Now I've only drawn a little rectangular billet, just giving me 5mm of stock all the way around. If you've been given round bar to work through, you just simply draw a round bar. We can use that for two things. We can machine the excess stock off the top face using the rectangle as a boundary, and we can simulate to it. So we get a very accurate simulation of everything that's going to happen on our machine tool before it even goes out onto the shop floor. So let's have a look at putting some tool paths around it. So we're going to get to our stock tool paths. I'm going to select facing. And as you can see, the prompt down at the bottom of the screen is asking me to select the boundary of the face. Well, the boundary of the face is the rectangle, so you just simply left-hand mouse click and then right-hand mouse click to accept. Once it will then take you into your tool selection. Now, OneCNC will also remember whatever tool it used last to do any particular operation. If that isn't the tool you want to use, you just simply left-hand mouse click on it. That will then take you into the Favorites tab. Any tool you've got labelled in your library as a favourite, tools you use on a regular basis, you can then pick them from here. If the tool you want isn't there, you can simply go into our libraries. Now everything there from ball end mills, bull end mills, facing tools, threading tools, engraving tools, spot drills and reamers. Completely editable by yourself. You just need to select the style of tool and the size of tool you want to work with. Now they are very, very simple things to create. All they need is the material type, a tool number or a library number, the diameter and tip radius if it's got one, the flutes and load per flute OneCNC uses for its feed rate calculations, and then you have flute length, tool length and holder style, which are all completely editable. You can create your own holders. It uses for collision detection purposes. So I'm just going to select OK. You'll have seen the speeds and feeds flash very briefly. That calculation has been made with the amount of flutes and load per flute we've set for the tool in conjunction with the stock material. If we left click on the stock material, everything there from aluminium, brass, copper, bronze, plastics, all the way down to free cutting stainlesses and titaniums. Again, completely editable by yourself. You just need to go into enable editing and you'll just see the surface speed requirement and the style of tool, whether it's high-speed steel, carbide, tick-end coated high-speed steel, tick-end coated carbide, cobalt, ceramics, diamonds, taps, drills. You just basically select the one of your choice and select OK. Now, just because OneCNC's calculated them out, if you're in a bit of a rush and your libraries might not be set 100% correctly, you can obviously override any feed rate or any spindle speed. Okay, so we'll give it a tool number. Coolant options, none or 1 through to 4, all controlled by post processors. 1 is generally an MO8, 2 through spindle coolant, 3 and 4 could be air blast, oil feed, whatever options your machine's got available. So we'll just go with coolant number 1. Work offset, G54 through to G59 as standard. If you want to use extended offsets, you might want to work with G54.1, G54.1 P2s. You can type in any work offset of your choice. If you work with Heidenhains, you'd be typing in H values. So I'm just going to stick with G54 for this one. You'll see a fair few toolpaths in our system that have this adjust high feed rate option. And what that's telling you is when the tool leaves the material boundary to take another cut and all it's doing is changing position, it's not going to go into a rapid move. It will only go into a rapid move if it lifts off from one side of the job and rapids over the other to carry on machining. So the way to use it is to stick in a box, type in the maximum feed rate of your machine in millimeters, which might be 20 meters a minute. So we'll just type in 20,000. Each toolpath has an option for notes. Notes will allow you to type in insert grades, any specific information you've got for the setters, maybe sticking out a certain length, using certain form tools. Whatever you want to write in there is visible on your job sheets. So I'll just close it down. And we'll select next. You get a dynamic view of your drawing to help you out with the start and finishing clearances. Obviously, anything you type in here, the applicable boundary will give you a visual representation of where it is your tool's coming into. So, rapid plane in Z. How close do you want to wrap it off the top face of the part? I'd be quite happy with 10 mil just to start off with. Your plunge clearance is an incremental distance above your material top, and your material top is how much stock you've got to remove off the top face. So we'll just say we've got a couple of mil. And final point in Z. If you want to leave stock on to go over with another tool afterwards, 0.2, 0.3 of a mil, you type it in there. Just for this example, I'm going straight to finish. Retract at feed speed. Now I want to wrap it out. And material top from geometry doesn't come into play because 3-axis machining, you're plain set on the top of the job, everything is minus. Cut control. If you remove the tick from the box, it'll take one cut. If you put a tick in the box, if you want to go down in pet depths, maybe you want a roughing depth of 1 mil, so it'll take it off in 2 hits. And we can select next. Okay, so the approach distance. How close do you want your tool to come in off the boundary? Well, we've set 110% as standard, so the tool is going to plunge in off the boundary of the material, which is great. I don't want it plunging onto the top face. Overlap amount, if you want the tool to feed all the way off the boundary before it changes direction, again 110%. Toolpath angle, 0 is along the X, 90 is along the Y. I'm just going to go with 0. And then you have a step over distance. Obviously dependent on your depth of cut, I'd be quite happy with 60-70%. I'm only taking a shallow cut, or you can untick the box and type over a physical step over difference in millimeters. Toolpath style will allow you to spiral from the outside of the billet to the inside, zigzag from left to right, bottom to top, corner to corner, depending on what toolpath angle you've got set, or one direction. I'm just going to work with the zigzag for this. So I'm going to press finish. And there's our first toolpath on the screen. If I just rotate it around a bit, left click on facing, you'll see the tool is now doing its 2 depths of cut and this blue link line between the green cut lines. As I've told the tool it can leave the boundary by 10% of its tool radius, is where it's going into its high feed rate move. Now if I just go into edit on this toolpath, you'll notice something else. Each time I create a toolpath, it provides me with a template. Now this is a template that you can use if you have a family of parts, similar parts. So if you use the same diameter tools, the same depths of cuts, speeds and feeds, rather than create that again from start to finish, you can simply left click on the 80mm carbide face mill, which is what I've just created. You can also customize them and name them yourself, which we'll have a look at a little bit later on. So for now I'm just going to close that form down. Okay, so let's have a look at machining this outside profile. For this one we're going to use high speed pocketing. Again, the prompt down the bottom, we can select the closed or open boundary. Well, the open boundary is going to be my material stock, and the boundary, the island, is going to be the main profile. So we right click to finish. And what we'll do is we create a template for this one in our favorites. So I'm just going to save the setting, and let's call this one 20mm diameter, high speed open, and select OK. Okay, we're going to change the tool over in the libraries. We're going to grab hold of a bull end mill, and we're going to grab hold of a 20mm diameter. Now, any tool you can bring in from the diameter, you can modify. So maybe I just want a 0.5 radius on the end just for a bit of strength. If it's only sticking out 50mm long for collision detections, I can change all of these. So we'll give it a new tool number. Quite happy with speeds and feeds, and you'll see a feed control option. Obviously, that is the most restricting part of any toolpath. Now, you might be able to run at 1 meter a minute on the linear moves. You might have to slow down to 200 millimeters, 250 millimeters a minute in the corners, so it doesn't squeal. And this allows you to look into the corners at a given distance, whether it be by a percentage of the tool or manually in millimeters. I'll just go with 25%, and it'll allow you to slow down on certain size arcs, again either by a percentage of the tool or manually typing in the radius that you want to look for. Now, as I said earlier, if I could run at 1 meter a minute on the linear moves but had to slow down to 250 millimeters a minute into the corners, I'd have a reduction of 75%. So we can select OK. And as I said, I reckon I could get away with 1 meter a minute on the linear moves. So we can select next. Okay, so rapid plane in Z, I'd be quite happy with a couple of mil. Plunge clearance, be quite happy with 0.5. Material top is 0. Final point in Z, if we weren't sure, we have a solid model sat behind in the background. I can select Pick Z. I can find an anchor point at the bottom of the model and left click. That's telling us we're at -30. I've got a bit of a protective edge on this tool, so I'm just going to override that and go to -31. And I'm going to select next. Okay, so we can stay with inside the boundary with high speed closed. We can start outside the boundary with high speed open. Traditional is a style of toolpath you would normally get pocketing on a conversational unit, and you have a high speed zigzag. So we're going to go with high speed open. Because I'm starting in outside the boundary, I'm going to plunge. Step over distance and depth of cut obviously work hand in hand. I've got a 20mm diameter cutter, more than enough flute length, so I'm not really too worried about rough index. So it's going to be the radial engagement, the auto step over, that controls the load of the tool. So let's say I'm quite happy with a 30% step over. So I'm doing a 6mm radial cut. Do I want to leave anything on the sides? Well, yes, I do, because I'm going to go around with a finish pass afterwards, whether it's with the same tool or a different tool, but I want to leave stock on there. Tolerance of the tool path is fine with 5 microns, and if you have a draft angle on a part, you can give it a wall taper. So I'm just going to select finish. Give it a few seconds to calculate out the tool path, and you'll see the tool is radially moving in at its 20 to 30% radial engagement, which I've given it. And again, the blue link line in between the green cut lines is where the tool is going into a high feed rate move. So let's have a look at machining these pockets. I'm going to go with high speed pocketing. I'm going to select both of these boundaries and right click. And again, I'm going to create myself a template for this one. So I'm just going to tell it to save the settings. And again, I'm going to use a 20mm. This time with a 1mm rad, and I'm just going to call that high speed closed and select OK. So we can give it a new tool number. Just modify the radius on the front page to 1mm. Quite happy with the speeds and feeds, so I'm going to select next. Final point in Z, just going to use Pick Z. Find a base of the pocket at -25, and we can select next again. This time we work into closed, stay inside the boundary. You can plunge or you can ramp. Well, if you've got a pre-drilled billet, been out to heat treatment possibly, you've got a casting where you've got a specific place you want to start in, you can use plunge, and you can force the machine to take an entry position of your choice. I'm going in with a solid part, so I'm just going to get OneCNC to sort it out itself. Again, if you want a ramp helix, you can force it to start in a position of your choice just by drawing an arc on the model where you want it to start. Ramp angle, be quite happy with 3 degrees. Helix diameter, let's say we're going to go in at 15 mil. It gives you a minimum and a maximum diameter. I normally go about halfway in between. Step over distance, again, let's say the tool can do 30%. I want to leave stock on the sides, not really leave anything on the bottom, just so you can see the finished profile a little bit easier. And I'm going to select next. Finishing options, as I said, if I want to go around with the same tool afterwards, and why not? Let's go with the same tool. I'm just going to say finish around the bottom only, and compensation. So we've got G41, G42. We're going to use wear away. And we're going to select next. Enter and exit. I'm going to use line and arc for both. Leading radius, I'd be quite happy with 3 mil. Leading angle, quite happy with 90 degrees. Start line length, just a couple of mil just for a bit of safety. And I'm going to copy those over to the exit values. And I'm going to select finish. Now we have our 2 pockets high-speed machine closed. So let's finish mill this profile. So we're going to go for mill profile. We're going to give ourselves a start point. Give it a direction. That will then track the profile all the way around and take us straight into our tool change. So we're going to change the tool over in the library. Let's say we're going to use an end mill. Let's say we're going to use a 16 mil diameter and select OK. So we can give it a new tool number, speeds and feeds. Final point in Z. Again, we could use the pick Z if we'd forgotten it was minus 30 mil. Maybe just go a little bit past, minus 30.5. And we can select next. Cut levels or ramp, well, I'm coming in outside the material, so I'm quite happy with cut levels. Step over distance doesn't come into play unless you're using removal amount, which is a roughing cycle to take any excess stock away. We've already removed the excess stock with a high-speed pocketing option. So do I want to leave stock on the sides? No, I don't. So next. Finishing option, I've got plenty of flute length, so I'm quite happy at the bottom of the profile, bottom only, and compensation options at control, so I've got G41, G42 cutter compensation. And next. The overlap amount is a distance from when the tool engages the profile to when it leaves the profile. And that's just to help improve your blend in, blend off. Leading radius, again, I'd be quite happy with 3 mil with a 90 degree approach and a couple of mil start line length. So I'm just going to select finish. So let's have a look at just putting these chamfers on. I'm going to go for chamfer and edge. Again, I'm going to select the base of the chamfer, give it a direction with the arrow, and right click to finish. Okay, I'm quite happy with the chamfer tool I've already got in there, so we'll just give it a new tool number, and we can select next. Quite happy with the clearance form. And as you can see, you have position number 1 or position number 2. Well, if you're just putting a small breakage on a model that hasn't got a chamfer built onto it, you use position number 1 and you just simply give it the size of chamfer that you need. We're working to an extracted edge off the base of a chamfer, so we're working to position number 2. So we swap over to bottom, and all we then need to do is give it a distance. You want the calibrated edge of the tool to go past the edge of the chamfer, so we'll just say 1 mil, and we can select next. Leading lead out style, be quite happy with line and arc again. Leading radius, 3 mil, 90 degree approach, couple of mil start line length, and we'll copy those over to the exit values. So we've had a look at creating templates for high-speed machining and profiling. Let's have a look at creating a template that can be used on another part for doing these 5 holes. Okay, so we're going to go back into our stock toolpath. This time we're going to use Drill Hole Wizard. And if I just move that form out of the way, you can see what it's done. It's found 5 holes and it's found those two radius in the corners. Well, they're partial circles from geometry, but all we're really interested in is those 5 holes on there. And as you can see, it's telling us it's got a 10mm diameter bolt hole, 8mm deep, down to -30. So what we have there is a coordinate, and the smallest hole is 10mm. So we're going to accept those holes, and we're going to select next. We're not using material from Geometry Top. We'll have a look and see what that does on another sample. So I'm just going to turn that off. I'm just working on a flat area. Start point in Z, I'd be quite happy with 5mm. Rapid plane in Z, I'd be quite happy with a couple. Plunge clearance, I'd be quite happy with 0.5. And material top is 0. We can select next. Okay, so we want to spot drill it first. So I'm just going to left click on center. I'm then going to double click on center, and we can select our tools. I'll be quite happy with that for the first tool, so we'll give it a tool number. Quite happy with the speeds and feeds, and we can select next. So you've got machining cycle and automatic drilling. Automatic drilling is G-code output. Machining cycle brings in your post-processor. So we'll have a look at machining cycle. Hole depth, going to use absolute. I just want to put a little spot in there, so we'll just say -3mm, and we'll select next. Okay, well, there you have your post-processor options, G73, G81, all the way through to G88. I'm quite happy using the G81, don't really want it pecking. Retrap mode of G99 or G98. G98 will bring it back to rapid plane in Z. G99 will bring it out to its plunge clearance. So we're going to use G98 and select finish. Okay, so I want to drill it next. So I'm just going to change the tool over in the library. Let's grab hold of our 10mm drill and select OK. Give it a new tool number. We're going to use machining cycles. Still working absolute. The part is 30mm thick. May have 3 or 4mm in the vice jaw. Probably want to go all the way through it. So let's say billet's 35mm. So I'm just going to say -35. That is the point depth, as you can see from this little icon. If I want full diameter drilling, the option to drill through at 35mm, you just put a tick in the box. You'll see the icon that will then change. You're now doing full diameter drilling. You're drilling through full diameter at 35. I'm going to let this drill peck, so I'm going to use a G83. Peck depth I'm quite happy with, say 6mm. Retrap mode of G98 and finished. And let's just put this counter bore on the top. So I'm just going to select counter bore. I'm going to change the tool over in the libraries. Let's say we're going to do this with a 12mm cutter. So we'll give it a new tool number. Quite happy with the speeds and feeds. And I want to helically mill this one. So we've got a diameter of 16mm. Absolute, we're going 8mm deep, so -8. We're just doing this as a finishing cycle, so I'm going to leave nothing for finish. Depth for turn, let's say 1mm, and finish. You get a cross-sectional view as you're doing this, so you can keep a close eye on it visually. And as I said, we're creating templates, so we can use this on another part. So I'm just going to select Save As, and I'm going to call that 16mm counter bore, 10mm hole, and select OK. That will they'll be in your hole definition, so you can obviously select any previously machined hole from this area, and that will drop it straight into your program. So I'm going to select finish. So let's have a look at simulation. I'm just going to right click on my toolpath group, going to simulate rest. I'm simulating to a boundary. Top of the job I said I had a couple of mil on there. Bottom of the job we said was 35mm. All we need to do then is select the boundary for the simulation and right hand mouse click. Now we can obviously speed the simulation up or slow it down on the bottom left hand side of the screen, and you'll see the tool is radially moving in at its 20, 25, 30% radial engagement, whatever you've set. So you get constant load on the tool at all times. You're utilizing the full flute of your tool, so you're not just going around at 5-10 mil, reducing the first 10 millimeters of your tool to nothing, so it either needs chopping off. This way you can obviously send the entire tool off and just be refurbed. So it's a very efficient way of using your tooling. As you can see, the whole thing's being collision detected, the length of the tool and the shank and holder collisions. And as you can see, it's just radially moving into those corners. Where you see the tool changing into that light brown at the bottom of those pockets is where it's going into its high feed rate move. It will only go into a rapid move and turn red if it lifts the pocket and goes to remachine somewhere else. Finishing around the pockets and now finishing around the outside profile. Just putting the chamfer around the outside profile. Spot drilling, and counter boring those 5 holes. Okay, but when you've got parts with a lot of options, a lot of operations and features, things can get missed. We do have an option for rest, and basically rest compares what you've done back to the model you've got in the background, and it's going to show you red is an excessive amount of stock left on. Yellow, it uses the term areas of interest, not quite right, go back and have a look, and grey is completely machine to model. So when I select OK, it's just going to compare itself back to the model and show me what I've got. Now, as you can see, I've missed those 2 chamfers. Obviously the bottom of the part is red because that needs flipping over and machining off, but you can see straight away before this program goes out to the machine, I've missed something off. So I'm just going to go back and put that right. Now, editing programs is really very simple. I'm just going to right click on my chamfer option and repick path, and then I'm just going to give it the start point again for the outside boundary. I can then pick the inside boundary both sides and right click to finish, and now I've got a chamfer going all the way around that part. So the job is now ready to send out to the machine tools. Okay, so let's get ready to send this out to our machines. I'm going to right click on the toolpath group. I'm going to go into post group. We're going to grab our post processor. We initially said that I was going to do this with a Haas machine. Description, we'll just call this one demo. Program number, obviously whatever program number that you like. Part number. The author is me. I've logged onto the system. Work shift doesn't come into play unless you're using 5-axis machines where the pivot will point. Table load move if you have twin pallet machines. And notes. Anything you type into that particular area is visible on your job sheet. You might be telling the setters to set Z0 32 mil above vice jaw, or any other information that you want to put in there. Torque pressures, fixture numbers, anything you like. And then we just select job sheet. We'll just view that as a PDF so we can go through it. And as you can see, all the information that we put at the top, demo, post, program numbers, drawing numbers, gives you cycle time from start to finish, so it's a good little bit for quoting. Group notes, anything you typed in there is visible by your setters or your operators. Gives you a tool summary with the amount of operations. If you do make a mistake in your tool numbers, it will come up here with an alarm saying duplicate stations are being used. If you then scroll down a bit further, you can see it gives you a crosshair to show you where the datum of the part has been set, along with the model and all of the tool paths going on the part. And as you carry on scrolling down, you can see it breaks each individual into the operation time, the maximum depth the tool is going to be going, the work offset being used, and all of the tool and station information. So we'll just close that down. You can obviously print it off or save it to your customer folders, and we can then post. First thing you need to do when you select your post processor is just make sure the file extension is set correctly. So as I'm posting out with a hash, it'll be .nc. You can obviously redirect this program wherever you like, customer folders, flashcards, memory sticks, and then you simply select save. And OneCNC will then bring out all of the G code applicable to your machine tool. So there we have a job from start to finish, importing a solid model, extracting all the edges round, creating ourselves a tool sheet, and visually checking the simulation. So let's have a look how these templates can improve our setup or speed of programming on other parts. So let's bring in a similar part. I've already put some geometry around those parts just for the billet size and the profiles. But as I say, this is a family of parts. They are pretty much the same material and tooling. So first thing we want to do again is high-speed pocketing. So when we select the high-speed pocketing, the boundary and the island, we're now going to use our 20mm diameter high-speed open one. So you see the tool change, all the speeds and feeds. I can just push through this form. I obviously need to check the depth of the profile, so I'll just drop down and check the depth. Slightly shallower in this case, -25, so we'll just override it and tell it -26. As I say, all the rest of the information will remain the same. Quite happy with the plunges, quite happy with the speeds and feeds. So as for the two pockets, we're going to go back into high-speed pocketing. We're going to select the boundaries for the two pockets. We're now going to use the 20mm closed, and again we're going to push through this form, making sure we do check the Z depth at the base of that pocket. Slightly shallow again, 15, but apart from that I'm quite happy with all the information OneCNC has been collecting within inside these toolpaths. And as for the holes, drill hole wizard, you can see the hole size is the same. Quite happy with my clearance form, so I can just drop straight into my hole definitions and select the 16mm counterbore and select finish. And you can see very quickly you are building up a program without any effort whatsoever. So it's making your programming times far more efficiently, and with those high-speed toolpaths you will be increasing the efficiency of your machine tools. Now these holes are all on the same Z level. Let me show you how holes via geometry works. So if we bring in another option, you can see this has got 8 holes of similar size, but they're on different Z levels. When you work with a model without any extracted geometry, you would need to do that in 2 separate cutter paths, one at the top of that plane and one at the bottom of this. The difference being is you now use the geometry that you extract off the top of the holes as the 0 for the start point of your holes. So we're going to go back into Drill Hole Wizard. As you can see, it's found all the holes in there, 5mm diameter, 10mm diameter, and the 5mm ones on the base. So I now want to select both of those hole types and select next. Now we're not working on a flat face, we're working using geometry, so we simply select use from the material top. I've already created this hole once, so I'm going to grab my M6 tap and select finished. And as you can see, it then puts those holes in accordance on the height of where that geometry starts. So even if you're only spot drilling various different sizes of holes, again it makes your programming time a lot quicker. Now due to time restraints, obviously I can't go through everything that this version of software is capable of doing, but there are help functions built in for every icon on the screen. If you're not sure on how to do threading, and a lot of people need reminding until they get familiar with the software, you can just simply left click on threading, press F1 on your keypad, and it takes you straight into a tutorial on how to thread mill. Now this tutorial is available for every icon, as I said, on the screen. It helps learning the software so much more easy, whether or not it's for toolpaths, whether it's for dimensioning, whether it's for your transform options that allow you to copy, move. Again, you just simply left click and press F1. Now, because there are several options available within inside of the transform options, you don't have to escape out to see what copy and move does. You just simply left click on these other options. They are all now live. Well, as I say, I can't possibly go through every option that's available in OneCNC XR7 Mill Express, but as you can see, it's a very powerful drawing and toolpath version. So thank you for watching. If you have any questions, please get in contact with us at OneCNC UK, and I hope to speak to you soon. Bye bye.